Thank you very much. So I'm going to talk a bit about Darcy's influence in art, but also talk a bit about Darcy himself and his own art interests, and about some of the things that we've been doing in the museum. So Darcy actually, from quite an early age, grew up in quite an artistic background. His uncle was actually a professional painter. We have this lovely painting of the young Darcy, aged about 5 or 6, painted by his uncle, George Clark Stanton. It's just about the only image that we have of Darcy that actually shows his bright red hair. Classic Scot, he had this wonderful ginger hair. He was later described as a veritable lion of a man. And at the age of just 24, Darcy was appointed to the first chair of biology at what was then University College Dundee, now the University of Dundee, which had only just been founded the previous year. And they were very much looking for young, dynamic, enthusiastic personalities to take on the new chairs. This is Darcy's office on the left here, crammed full of all his stuff. I very much base my own office on this. And one of the laboratories, and as you can see, all of the benches there laid out with specimens for teaching. Very quickly, Darcy realised that what he needed in order to teach his subject was a zoology museum. And in a relatively short space of time, and with very little money, he managed to build up what at the time was actually one of the largest zoology collections in Britain at the time. And it's the remains of that collection that I now help to look after in Dundee, and we have all of the traditional things associated with zoology museums. We have skeletons, we have stuffed animals, we have things in jars, we have a lot of Darcy's original microscope slides. But we also have a lot of his very beautiful original teaching models and charts, which are really gorgeous works of art in their own right, and we can really tell Darcy's kind of aesthetic sense, I think, from looking at these beautiful objects. And it's also worth pointing out that Darcy, as well as having a great love of art and an interest in art, actually had a particular area of research in art that he published on significantly. Darcy was a great lover of the classics. His father taught classics and in fact became professor of Greek in Queen's College, Galway in Ireland. And so Darcy very much inherited both a love of biology but also a love of classics. And a number of his publications, apart from On Growth and Form, actually bring together these two things. And in particular, he had a real interest in the representation of animals in ancient art, so things like these ancient Greek coins, for example, and he published a number of papers on this. And the first example we know of an artist directly drawing on Darcy's work came in 1900, when Darcy actually commissioned an artist called George Dutch Davidson to create a series of murals for his study. Davidson was part of a group of artists in Dundee at that time who were really at the centre of the Celtic revival movement that was very fashionable in Scotland at the time, and also drawing very heavily on the symbolist movement in Europe. I should say I don't actually know whether the fact that he had this middle name Dutch means he had any Dutch connections, I'm not sure. But anyway, Davidson was commissioned to create these murals for Darcy's study. Sadly, he actually died before carrying out this commission, and the only thing that survives is this one pencil study for one of the murals, which shows Orpheus and the listening animals. So they were all meant to be based on scenes of classical mythology that dealt with zoological themes. So he was very much bringing in both the classics and the zoology side, but there are also a lot of interesting kind of mathematical patterns going on in the drawing as well. And one of the things that's really interesting about On Growth and Form is that a number of the people that directly inspired it were also people that brought together art and science. And they included Ernst Haeckel, the great German biologist, who did these wonderful and slightly fanciful drawings of radiolaria and other minute organisms. Theodore Cook was an English art critic who wrote a number of books about spirals in art and nature. Of course, spiral patterns were one of the things that really fascinated Darcy. Particularly interesting was an Austrian, Hans Seebraum. Seebraum was a biologist who worked at a place called the Vienna Vivarium, which was this extraordinary experimental biology institute founded in 1903, which was really one of the first to look at biology from an interdisciplinary point of view. So there were chemists and physicists and mathematicians all kind of working together to tackle biology. But he was also an artist and actually was invited to publish a number of illustrations in the very influential Vienna art journal Versacrum. And also less well-known figures. Gerhard Hyman was a Danish paleontologist who was very much ostracized by the sort of scientific clique in Denmark because he didn't have formal training, he wasn't a member of their society. But Darcy very much recognized his ability and not only drew on his research, but also invited him to draw some of the famous transformation diagrams in On Growth and Form. And it's interesting that these diagrams themselves, which of course we've seen reproduced a lot this evening already, are also based on the work of an artist, namely Albrecht Dürer. In his 4 books on human proportion, Dürer drew these very interesting drawings showing the different relationships between different forms of human head. And that's essentially what Darcy used as the basis for these diagrams. It's also worth pointing out that a number of Darcy's colleagues in Dundee were very influential in some of the diagrams. So for engineers and architects, probably the most famous chapter is the one about form and mechanical efficiency. And it has these very famous diagrams where he compares the structure of the Forth Bridge to the skeleton of dinosaurs. Those illustrations were actually provided by the professor of engineering in Dundee, Thomas Claxton Fiddler, who was an expert on bridge construction. And this is the original correspondence where he draws those diagrams for Darcy. And there are also 2 unsung women heroines in this story, Darcy's assistant, Doris McKinnon, and one of his students, Helen Ogilvie, because they were actually responsible for the illustrations of the book and sourcing them from different publications and also drawing some of the illustrations themselves, because Darcy himself was not an artist. Now, we've obviously heard hugely about the influence in biology and in mathematics. The book has, of course, had a huge influence in many, many other fields. And what's interesting is that quite often the influence comes directly from the illustrations, from the visual quality of the book. And just as one example, I've put up these 2 things to show the influence, part of the influence that the book has had in geography. You might have seen these before. They're called cartograms, and they're a way of visualizing data about the world, basically inspired by the transformation diagrams. So this one at the top here is the world according to GDP wealth. So you'll notice that North America and Europe have been hugely inflated, while South America and Africa greatly decreased. By contrast, the bottom one is the world according to available water resources. So you have a very different picture. So it's basically taking this model and then transforming it according to the particular data as a way of just helping to visualize that. But obviously what we're here to talk about particularly is this extraordinary influence that the book has had in art and design and architecture. I've put up the cover of Martin Kemp's book, Seen Unseen, which is a particularly good source of information. There's a whole chapter in this about the influence that the book has had in art. And so this idea that there's this hidden geometrical order in nature, and that organisms are not just static things, but are constantly shaped by the physical forces acting upon them, has had a huge influence on many generations of artists. The first major figure that we know of was the English sculptor Henry Moore. He read the book while he was a student working in Leeds, and it clearly influenced these extraordinary biomorphic sculptures that he created. And during the 1930s, Moore drew a whole series of drawings called transformation drawings, which have different forms morphing from one to another, which then informed his sculptures. In the 1930s, there was this group of very influential modernist artists working in the south coast of England in St Ives, and they were all reading the book and getting really interested in it. And they included sculptors like Barbara Hepworth and Naum Garber, who were creating these very geometrically precise but very organic-looking forms. It wasn't just in Britain. Paul Klee, we almost certainly think, was reading the book. We haven't quite actually found definite proof, but suddenly in the 1920s he starts to produce a whole series of works that feature plant growth patterns, which certainly suggests he was reading it. The Bauhaus artist Moholy Nagy came to Britain in the late 30s, found out about the book there, and he refers to it a couple of times in his book Vision in Motion, published in 1947. And that book then became really quite an important text for a whole generation of artists that came after him, including a group based in London who became known as the Independent Group, the most famous of whom, Richard Hamilton, curated this exhibition called Growth and Form at the Institute of Contemporary Art in London in 1951 to time with the Festival of Britain. And this was a really influential exhibition. It was the first installation art show in Britain. The entire content was made up of scientific drawings, diagrams, photos, many of them taken directly from On Growth and Form, but presented as if they were works of art. Hamilton later moved up to Newcastle in the north of England, and together with another great Darcy enthusiast, Victor Passmore, they introduced a new syllabus called the Basic Design Course, which was then picked up at many other art schools around the country. And it basically completely transformed the teaching of art in Britain for several generations. And many of the exercises in that course were based directly on growth patterns from Darcy's work. In America, Jackson Pollock and the abstract expressionists were also reading the book, and for example, there's a famous chapter in the book about splash patterns that we might imagine that Pollock was very interested in. And certainly one of the interesting things about Pollock's work is, although it appears to be really chaotic and random, there's actually this very careful underlying structure to it. Salvador Dali was also reading the book, and he refers to it repeatedly in a book that he published in 1949 called 50 Secrets of Magic Craftsmanship. In particular, he reproduces several of the diagrams of radiolaria in that. And some of the pioneers of computer art, like Desmond Paul Henry and Roy Ascott, were also really interested in the book. Land artists like Andy Goldsworthy and Robert Smithson as well, creating these amazing geometric forms in the landscape. That, of course, leads us on to architecture, and some of the most famous architects of the last century were also reading the book and becoming really interested in this idea of growth patterns in nature. Le Corbusier, for example. Corbusier was also a graphic artist and created a number of graphic pieces that also relate to Darcy's work. Mies van der Rohe, who later introduced On Growth and Form as a set text to all of his architecture students. And Darcy talks in On Growth and Form about particular lightweight structures like dragonfly wings and indeed soap bubbles. So we don't have any real soap bubbles, but I can at least show you a picture of a soap bubble. And that had a huge influence on the development of lightweight structures in architecture, like Buckminster Fuller's geodesic domes, Frei Otto's Olympic Stadium in Munich, which really transformed the possibilities of architecture in the mid-20th century. And I've determined to get a Dutch architect in, so Lars Spijbroek has also frequently cited Darcy Thompson as a key influence on his work. And many other figures today, like Norman Foster, for example, Cecil Balmond, and many others hugely influenced by the book. So I want to come back to Dundee. Darcy's original museum was sadly demolished in the 1950s. A lot of his collection was either lost or sent elsewhere at that time. Various other forms of the museum existed over the years, but it was only in 2008 that we were able to create a new sort of proper form of the museum, which we've now named in Darcy's honour, and which is now open to the public. And one of the things that we've been really keen to do in that is to bring together both art and science and actually show works of art alongside works of science. So the collection is still used for teaching life sciences, but it's also increasingly used for teaching art students as well. At the University of Dundee, we have a particularly fine art college, Duncan of Jordanson College of Art and Design. Many of the students regularly use the collection. And we're really keen to both show art and specimens together in the museum, both in permanent terms, in terms of things that we're actually buying for our collection, but also in terms of temporary pieces as well. This is part of a project that we did with some postgraduate students at the art college. And we've done a number of exhibitions looking at the influence that Darcy's work has had, and particularly one of the things we've been keen to do is invite artists to come to the collection and draw on Darcy's actual specimens, but also find out more about the work, and then obviously commission new pieces as a result. But a couple of years ago, we were very fortunate to get a grant from the Art Fund, which is a UK charity that helps museums buy work for permanent collections. And that enabled us to buy works by some of these key artists over the last 100 years, including Henry Moore, Wilhelmina Barnes-Graham, who was one of the St Ives artists, Victor Passmore and Richard Hamilton. We were able to get the original catalogue from the Growth and Form exhibition. But also modern artists as well. We were very keen to work with contemporary artists who are also drawing on Darcy's work. So Susan Durgis, for example, is a photographer who makes these really large-scale photographic pieces without using a camera, basically laying large sheets of photographic paper down in rivers and then exposing them with light, and you get these amazing patterns forming. Mark Wright is a painter who works on very large-scale oil paintings, deliberately sort of playing with concepts of scale. Peter Randall-Page, very renowned sculptor who creates these amazing forms that look like sort of cellular growth patterns. But also, because of the sort of link with development of systems theory and computers and so on, we're really keen to work with digital artists. So Bruce Jarron, for example, is an artist who has created a 3D computer version of the transformation diagrams and then used that to create various chimeric forms, which he then produces as 3D printed sculptures. Daniel Brown is a digital artist who's created this series called Flowers, which grows endless flower patterns that never repeat themselves. But all of the textures and patterns and shapes from those actually derive from imagery from specimens in our collection. Andy Lomas is a really interesting example of someone who works both as a special effects designer but also as a fine artist and creates a number of prints using logarithmic growth patterns. We had a number of artists in residence working in the collection. We've commissioned a print folio from some of the leading artists teaching at Duncan of Jordanson. Various publications have come out of the project, and there'll be various other things happening this year as a result of that. And one of the other things that's been really nice is since we started doing this, various other parts of the university have realised the benefits of bringing together art and science. And so in the research part of life sciences, there's now a new research gallery called LifeSpace, which brings together both artists and researchers in the life sciences. Just to finish with a couple of other things that we do, we run Darcy's Facebook page, so if you want to be friends with the great man, now's your chance. And we've also set up the website, www.ongrowthandform.org, to map all of the various activities that are going on, including this event tonight. And we have a restaurant in Dundee called the Darcy Thompson. So if any of you come to visit us, recommend that you eat here. We were involved in helping with the design, and they do very good desserts, so I do recommend it. So I shall stop there. Thank you very much.
Thank you, Matthew Jarron, for everything you said, and that was a lot, huh? Wasn't it? Maybe I'll just finish with one last question, and that would be like, what would be the ideal to achieve with the museum in one
word?
Is that possible?
No.
One sentence. Be really ideal.
Yeah. Well, gosh, there's lots of things we would like to achieve. I mean, one of the things we've obviously been very keen to do is try to get Darcy's name out there more. He's one of these biologists that has huge influence, as of course you've heard tonight, but actually still most people have never heard of him. So more people finding out about his work, more people actually coming to use his collections, getting more artists, getting more scientists interested in his work. But particularly, actually, it would be nice to have a better space to show it in, because at the moment we're only able to show a fraction of the collection. So it would be, if we had a huge, great building, we could show much more. So,
okay.
But there's loads of things we can do.
Yeah, okay. Well, then please give an encouraging applause to achieve this, because we need it.